And welcome to today's video on domain and range. And remember, domain and range is when we are talking about functions. Okay, you can't take a domain and range of any equation, right? And what is a function again? A function is a mathematical expression with an input and an output, as well as it needs to be defined on its domain. Okay, to be defined on domain. And the domain, if you don't remember, is all the possible input values. So the domain is going to be on the x-axis. Okay, and I'm just going to say possible x values. And when I say possible, what I mean is it's possible to plug in to your function and obtain an output, right? That's what I mean when I say it's possible. Okay, so remember, domain is x-axis. Right? Y-axis is your range. And if you don't remember what range is your possible y values, right? Really, your domain is your input value, right? Is related to your input value, while your output value is related to your range. Okay, so let's go look at that, and let's move on to some examples here. So our first example is going to be f of x equals 1 plus x squared. Okay, so we don't have anything in the x that would make this undefined, right? There's nowhere that this function, we can just say it's y, right? Remember that f is just your function name, right? So we can just say it's y equals 1 plus x squared. Okay, so I don't see anything on the x, on our input, that would make this undefined, so it's just going to be negative infinity to infinity. And range, let's see, so x squared is always going to be increasing, and we know the behavior of x squared. You've probably seen this, right? This is x squared. Okay, so if we graph 1 plus x squared, excuse me, it's going to look like this, right? And this is going to be 1. Okay, so our range is going to be including the point. Let me just rewrite that so there's no confusion here. Square bracket 1, positive infinity. Okay, so this is how you want to define a domain and a range. Your next question might be, what are these round brackets and what are these square brackets? Okay, round bracket means approaches value, right? So it never actually hits it. So I could say, if I put parenthesis 1, it would mean it would never actually hit this point right here, right? Okay, so that's why we had to put a square bracket, so it included that value. Okay, so square bracket is I guess hits value, right? Okay, so this is always going to be important. You'll also might have, if you're looking at a graph, like a piecewise function, you might be graphing a piecewise function, and you'll have a function that looks like this, something like this. Okay, if this looks familiar to you, this, right? These are the same. Okay, so this, when it's a filled in dot on a piecewise function on a graph, just think it's also like a square bracket. Okay, so hopefully that makes sense. Hopefully that didn't confuse you too much. Just know that when you're doing anything on a graph, right, if it hits the value, you want a square bracket. If it doesn't hit the value, then it's a round bracket. Now let's talk about real quick, why do we have to put round brackets around negative infinity or positive infinity? Well, it's because this is very important now. Positive infinity is not a value. It's a true value, right? It is not definable, right? We can't define infinity. Infinity is not something we can, we can do math with, right? You can't subtract 1 from infinity and know what that value is besides just knowing it's infinity minus 1. So that's when we know it's just approaching a value. We don't actually know what infinity is. So hopefully that makes sense. Okay. All right, and our next example is capital F of x equals 1 minus root x. Okay, and I see that square root in there, so I know x is going to be greater or equal to 0. But let's just make a quick note of that over here if you were confused. So we can never have a square root of a negative number, right? This will be undefined. And remember, to be a function, it needs to be defined at all points. Okay, so we want this number in there, or x, to be greater or equal to 0. Okay, so that makes our domain pretty easy. We know domain is going to be 0 to infinity. And this is a square bracket, right? So a square bracket, what is a square bracket? When you see these square brackets, this means it includes points, right? Or I should say it includes the value, right? Because we're just talking about that x value. We're not actually talking about the xy point. Okay, and if we have parentheses like this just means approaches. Approaches value. Okay, and let's look at the range of this. Remember, ranges are y values. Okay, so we know, let's make a note. This is always positive. Okay, so if we have a constant 1, so if we're subtracting something that's always positive from a constant 1 right here, then we know the greatest value that we're going to have is going to be 1. So it's going to be negative infinity to 1. Okay, and let me just draw this graph real quick. And this is 1. Okay, it's going to look like this. And remember, just square root of x, just simply square root of x, looks like this, or starts at 0, excuse me. Okay, so let's keep that in mind. Okay, next example. All right, and since I just really want to reiterate our last example, I'm going to do another square root. I'm going to say this is 5t plus 10. I'm going to say it's equal to z of t. Okay, really we can just say this is, we can put any value in here. We could put 5x plus 10. As long as you can differentiate between what's the input and what the output is, then you can trade variables along all day long, right? Just make sure, if you're answering something, to trade back the values. Okay, so what is our domain? Remember, domain, we cannot have negative numbers. This is bad. No. So this has to be positive. So we can, or greater than 0, right? Square root has to be greater than 0. Okay, so let's just solve for this. Okay, so we got 5t minus 10, divide that by 5. Okay, so t equals negative 2, and our square root has to be positive. Okay, so negative 2 is going to be the smallest inputable x value, and we can include that point. Okay, so what's our range going to be? Well, I know it has to be 0, because equal or less than, or equal to or greater than 0. And there's nothing outside of this square root. Yep, so our range is going to be 0 to infinity. Okay. All right, next example. All right, our next example is g of x equals square root of x squared minus 3x. Remember, our square root, this value in here has to be greater than or equal to 0. So let's just set this equal to 0 so we can find our x values here. So let's factor. Right? This is your x. Okay, so if we know that these are, right, our points, let's look at the behavior of this graph, because it's easy to solve for this, but sometimes it's difficult to think about what the behavior of the graph is looking like. Because I don't know if this 0 is a min or a max, or I don't know if 3 is a min or a max. I don't know what the graph is doing. I don't know what it's doing in between 0 and 3. So let's just find out. Let's just plug in some values. Let's solve for some values that are to the left and to the right of all these. Okay, so let's solve for x equals -1. Okay, so you have -1 squared minus 3, 1. So you'll have 1 minus, or 1 plus 3, excuse me. That's going to equal 2. Okay, x equals 1. Do the same thing as above. 1 squared minus 3 is 1. Okay, so this is undefined, right? Okay, so don't need that. And what about x equals 4? I assume this is going to be defined. We got 4 squared minus 3 times 4. It's going to equal 16 minus 12. We have the square root of 4. So it's going to be 2. Okay, perfect. Okay, so if we know that our domain is going to be -infinity to 0, square brackets, and we're going to have this u. Okay, what is this? It looks like a u. It's called a union. Okay, a union is something that you use when a function is undefined over a certain interval, right? It's almost like you're kind of zipping it together. Okay, and what was our other value? 3. And I'll show you what this function looks like here in a second. What about our range? Well, we have a square root, so we know it has to be 0 to infinity. Okay, perfect. And let me just quickly just get rid of this, and I'm going to show you. I'm going to graph that function, this function, real quick. All right, so okay, it's going to have that same square root behavior. You guys saw square root of x, what the behavior of was that, and 1 minus square root of x. So kind of same behavior. Okay, and this is the 3, and this is a 0. Right, so there, right there. Sweet. Next example. All right, let's move on to our next example here. Next example is going to be z of t equals 2 over t squared minus 16. And there's a special rule, just like there's a special rule for ensuring that there's no negative number inside of a square root. There is a rule for this case. So say we have a k and we have some number in the bottom here, right? This number cannot equal 0. Can never divide by 0, okay? It's undefined if you do. Remember, to be a function, you want every point to be defined. Okay, so really, we don't want this t squared minus 16 to equal 0, right? We don't want it to equal 0, but we want to find what values of t can make it 0, because those are the values that we want to exclude from our domain, okay? So, t squared minus 16 equal to 0. We'll add 16 to both sides. Take the square root, both sides. And we have t equals plus or minus 4. Okay, so our domain becomes x cannot equal, and let me add that plus or minus. Okay, there's our domain, and we'll put our range down here. Okay, so if we can never divide by 0 here, oh, I see. This will never be equal to 0. So y cannot equal 0. Okay. Now let's look at the behavior of this graph. Okay, we'll say this is negative 4. I know there's likely going to be an asymptote here. Okay. And just by judging some of the values I'm thinking of, the graph should look like this. Right. In this case, your negative 4 and your positive 4 on the x-axis are your vertical asymptotes, and you'll have a horizontal asymptote at y equals 0. Okay, next example. All right, and our next example here is really combining elements from our last two examples where we saw we can't divide by 0 and we can't have a negative square root. Both of these are going to apply in this problem here. As you can see, we can't divide by 4 minus 4, right? And we also can't have a negative square root inside this. So this is going to make solving for our domain pretty easy. We know exactly what we need to solve for. Okay, so let's first solve for the case where we be dividing by 0. So let's set the whole denominator equal to 0, and let's just do some simple algebra here. Okay. So x squared is going to equal 25, so our square root of 25, so x is going to equal plus or minus 5. Okay, perfect. So in this case, x cannot equal this. Okay, when we look at the function here, we cannot have 5 plugged in here, or it'll to make our denominator 0. So we know there's vertical asymptotes at plus or minus 5. Okay. All right, now let's find that negative square root. So we want to find what the minimum and maximum values we can insert into this function and not get a negative square root. So we're going to set this equal to 0, the closest we can get to a negative, and let's solve for these x's. And I'm just going to kind of skip ahead here. Okay, so this is kind of our limits, right? So if we look at our domain, let's write this out. Our domain can be negative infinity to negative 5, and this is going to be a round bracket since we can't include it. And we have negative 5 again, and this is going to go to negative 3. I don't know why I did that. Negative 3, square bracket, union, square bracket again, And then this will be another round bracket, union 5 to infinity. Okay, so let's draw this out. Let's draw this out. This might look a little confusing. I promise it's not. It's not quite as bad as it looks. Let's get rid of this. Okay. So let's just draw a simple graph here. Okay, so we're going to have a vertical asymptote at -5 and +5. This is just 5. This is -5. Okay, and we have limits at -3 and 3. We can't have anything in between here, or we will have negative square root. So this is just kind of a void, right? Really don't need to think about anything inside here. Our graph's not going to be inside there. Okay, and now let's think about this. Okay, so if we have values that are decreasing, our function will be decreasing, so our graph's going to look like this. Okay, and then this will be coming like that. That's just somewhere right there. And our 5 looks something like this. Okay, so now you gotta see the behavior here. This out to the graph, this goes to 1.5, goes to 3, 1.5, if y'all want to know. It doesn't actually go to 0. Okay, and that's all you need to do for this example. Okay, on to this example, we have y equals 2 plus x squared over x squared plus 4. Okay, and we want to find the range. The range is what's important on this example. Okay, so what is our domain? And really, when we're looking at square roots, possibly in our function, that could make this undefined. Division, you need 0 in denominators, so can a 0 get in this denominator? Can x squared plus 4 equal 0? And it can't. So we know this is going to be all real numbers. Okay, so what about our range? That's what we're focusing on here. So to find the range of a problem like this, or a function like this, it's not super obvious, but just by visually looking at it, what we can do is we can switch our x and y's around in the function and then proceed to solve for y. Okay. And those y values, well, we'll just see. Okay, so we'll have x minus 2 equals y squared over y squared plus 4. Okay, we're going to multiply each side by y squared plus 4. This is just kind of an arrow sign if you've never seen this. So we have x minus 2 times y squared plus 4 equals y squared. Okay, now let's try to multiply some of this out. So we're going to have x y squared plus 4x minus 2y squared minus 8 equals y squared. Okay, and I want to get all these y's on one side. I don't like having x's and y's on one side when we're trying to solve for y. So let's combine all the y's onto one side. So that would be y squared minus xy squared. I'm just going to move it to the left here. Minus xy squared, and we have this plus 2y squared. And that's going to equal 4x minus 8. Okay? So let's factor these y squareds here. So we're going to have 1 minus x plus 2 equals 4x minus 8. Okay. I can kind of see the light at the end of the tunnel here. And this is 2. I'm not quite sure why the screen keeps getting messed up here. Okay, so we're going to have y squared. And this is really just the same as x minus 3. Okay. 1 minus x is the same as x minus 3. And this is going to be equal to 4x minus 8. So when we solve for y, follow along here, I'm going to divide by x minus 3, and then I'm going to take the square root. I'm just going to do this in one step since I'm running out of room on the bottom here. Remember, this can be a plus or a minus, right? So whatever our values that come out of here, whatever x values, can be a plus or it can be a minus. Oh, why not? I messed up. And we know that just based off of this, if we take a y squared equals 3 or something, took a square root of both sides, y would equal plus or minus 3. Just don't want there to be any confusion as to why this is a plus or minus right there. Okay, so what do we do next? Well, what we do next is we want to solve for this x. Okay, we want to see what these y's are that would make this undefined. Okay, so let's just move it back up here, and this one we'll do the negative square root first. Okay, so I'm seeing a couple things that could make this undefined. I'm seeing we're dividing here, and I'm also seeing this giant square root that this all sits under. Okay, so x cannot equal 3. Or I should say y. And really just imagine this x as f of x, okay? Okay, so x cannot equal 3. What about our square root here? We have 4x minus 8. Okay, so x cannot equal 2. Okay. Now we have our positive version. And we are going to get the same thing, because the only thing that changes is the sign in front of the square root. But that's not going to change anything inside this actual square root, right? Okay, so we're just going to get the same thing. I'll write that. X cannot equal 3, x cannot equal 2. Okay, and when we see these x's, right, after we've solved for this and flipped our variables, the x is the y. Okay, we have flipped our variables, so what you're looking at is really your y values, which means all we do for range is say y cannot equal 3 or 2. And there you go. You just found the range of a pretty difficult function. I hope you guys feel a little more prepared to take domain and ranges. It's not super hard. I always recommend to think graphically how something works And if you can't think of how something it looks on a graph, just make sure you do a little data table, X, Y, and this, usually if I have the idea of what a graph looks like and kind of what the general behavior of the graph looks like, I can almost always, look at a lot of these problems and know exactly what it's going to be before I do any math. It just helps you keep checked and go through these problems a little faster. But hope you guys have a great one, and I hope you guys can consider liking and subscribing, and you enjoyed the video. Okay, thank you, bye.